In this video, we are going to see about the Zener diode. How a Zener diode works and the IV characteristics and the applications of the Zener diode. Zener diode is otherwise called as breakdown diode. It varies from the PN junction diode in the doping nature. When the PN junction diode is heavily doped, it is called as Zener diode. We already know the PN junction diode works only in the forward bias condition. In reverse bias condition, it acts as an open switch. So in order to make the diode to work in a reverse bias condition, we are going for the Zener diode with a heavy doping, so that the Zener diode allows the current flow in reverse bias condition. It operates in the reverse bias. So reverse biasing, we know the polarities are reverse biased, that is the positive side of the PN junction diode is connected to the negative terminal of the battery and the negative terminal is connected to the positive terminal of the battery. So this is how a reverse biasing occurs. In Zener diode, due to the doping nature, different doping nature, it also allows in reverse bias. So this is the symbolic representation of the Zener diode. So it look like a PN junction diode. In PN junction diode, a triangle shape and a single line will be there. Here a Z-shaped line will be there. So this indicates the Zener diode. So like P-type material, the anode terminal, N-type material, it is the cathode terminal. In the below diagram, there is a band near to the cathode diode which indicates it is a cathode. With that terminal only, we can identify the anode and the cathode terminal of the PN junction diode. There are two types of breakdown conditions occur in Zener diode. One it is the avalanche breakdown, another one it is the Zener breakdown. Avalanche breakdown will also occur in the normal diode and the Zener diode at very high reverse voltage. When the value of the reverse voltage applied to the PN junction diode, it is very high, there will be an free electron. That free electron will gain the sufficient energy and it accelerates itself and it moves to the higher velocities, and these high velocity electrons will collide with the other atom, and so that the atoms will release the more free electrons, and the release of the free electron will again it goes to and bombard the other atoms. Thus the result, it will produce the high amount of electric current, so that the diode will start increasing rapidly. So this particular nature of the diode will destroy the diode in normal conditions. So we are making a PN junction diode to work as in reverse bias with the effect of highly doping nature. Usually the avalanche breakdown will occur at the greater voltage of 6 volts in reverse biasing condition. So what happens in Zener breakdown, in the sense, in Zener breakdown, when the applied voltage is nearer to the Zener voltage, the electric field is strong enough to pull that particular electrons in the valence band. These electrons will gain some amount of electric field from the parent atom, and it will break down, and it really so due to that small increase in the reverse voltage will lead to a larger amount of electric current, so that there will be a breakdown occurs. So the reverse current will also increases. So reverse current, it leads to the Zener breakdown. So on the whole, we can say the difference between Zener breakdown and avalanche breakdown is Zener effect will take place at 5.6 volt. Avalanche breakdown will occurs at 6 volt. And the Zener breakdown is due to the quantum phenomena, that is the tunneling phenomena. Avalanche breakdown is due to the movement of the electrons, and also avalanche breakdown will have the larger amount of current than the Zener breakdown. So this is the characteristic curve. PN junction diode's characteristic forward characteristics curve is same like that the Zener diode. So Zener diode will have the forward characteristics curve. As the new voltage increases, the diode starts conducting, it will be acting as an open switch. When the reverse voltage falls below the Zener cutoff breakdown voltage, the Zener breakdown occurs. That will be 5.6. Above 5.6, that is nearer to the 6 voltage in reverse bias, the avalanche breakdown will occur. So same like that, when we connect a diode, the Zener diode, in a reverse bias condition, a small amount of reverse saturation current will flow. This current is due to the minority carriers, and when we increases the reverse voltage, increased current will be happened there due to the breakdown occurs. And these are some of the specifications used in Zener diode. One such specification is Zener or breakdown voltage. It as said earlier, this voltage may varies from it actually starts from 5.6, so it also varies up to 200 voltage it will allow. And the maximum current flow in the Zener diode, it is called the maximum current, it is up to 200 microamperes to 200 amperes, and minimum current that is flown is the breakdown diode, that is below 0.7, it is a minimum current amount. And power rating, it is the maximum power that can be generated by the Zener diode, and it is usually the power will be the multiplication or the product of the voltage and current. So power P is equal to V into I. The V, that is the voltage across the diode we are giving, and the current that is flown due to the voltage we are giving. So power is equal to V into I. And thermal stability, diodes can withstand up to 5 volts, and the tolerance is plus or minus 5 volt. Zener resistance, that is the AC or DC resistance that has been developed while we are biasing that particular Zener diode. And applications of Zener diode can work as an voltage regulator. When Zener diode is used as an regulator, we can regulate the voltage in terms of when we increase the voltage, the resistance across it will be common, and when we increase the resistance, the voltage will be common. So this is how a Zener diode can work as a regulator. And it also used in the over voltage protection, that is before I said Zener voltage regulator. So by changing the loads, it can sustain the input voltage. By changing the input voltage, the voltage across the load will be the same. So this is how it can used as an over voltage protection. So if there is an input voltage fluctuation, that output voltage will be the common voltage from the load. So, and it also works as a clipping circuits like PN junction diode. So clippers, positive clipper, negative clipper, biased clipper, like that. So on the whole, the PN junction diode varies from the Zener diode varies from the PN junction diode in terms of doping, and due to that different doping nature, the Zener diode works in the reverse bias condition. In reverse bias condition, it can work due to the breakdowns. There are two type of breakdowns. One, it is the Zener breakdown, another one it is avalanche breakdown. Zener breakdown will occurs in the lesser reverse bias voltage nearer to the 0.5, and avalanche occurs at 6 voltage, above 6 voltage. Okay, and Zener breakdown due to the tunneling nature, and avalanche breakdown due to the bombardment or the electric field setup inside the junction diode. Thank you.